Hi and welcome. I hope everyone is okay. Now, in probability of statistician lesson, we will go on about Poisson distribution. But beforely, I want to give a brief summary what we learned the last lesson about Poisson distribution. Okay, we can go on, and the summary is when working with experimental data where the outcome or event occurs at the random in a given interval and the mean and variance are almost the same value. A Poisson distribution is a good choice to model the data further. We use the mean rather than the variance as the parameter to describe a Poisson distribution. So, please remember that we show the Poisson distribution x value in the Poisson distribution. Excuse me that we shows Poisson distribution lambda. Lambda means mean or or average. Average. So, uh, key point. A Poisson distribution can be used to model a discrete probability distribution. Please don't forget this situation. A Poisson distribution can be used to model of discrete distribution, in which the events occur singly, at random, and independently. These key words, it's very important for us if you want to decide a distribution is a Poisson distribution or not. Please notice that your events should be singly, at random, and independently in a given interval of space or time. Your evently occurs in a given interval or space or time. For example, 1 square meter, a given event, or in a time, or determine a type. The the mean and variance of a Poisson distribution are equal. Hence, a Poisson distribution has only one parameter, because in Poisson distribution we have only variance or mean. So x value, Poisson distribution, and it means lambda or mean. Let us explore some example. To take to take away some of the pressure from an accident and an emergency hospital department during weekdays, a minor injuries clinic opens. To determine a possible staffing requirements, the following data for 250 times in 30 minutes intervals are collected. For example, please notice that the table number of patients arriving per 30 minutes, or it means X. For example, 0 patients come to clinic 45 times in 30 minutes, and 1 patient come to clinic 81 times in 40 minutes. 2 patients 58 times come to clinic, and 3 patients 40 times come to clinic, and 4 patients come to clinic to 22 times, and 5 patients come to clinic 4 times, greater than 5 patients 0 time. So if you sum up some of these values, you should find 250. This means our data, the number of data or observation. These observations about please notice that in 30 minutes, how many patients come to clinic. For these data, the mean number of patients per for 30 minutes interval is 1.7 mean. Please remember that if you want to work out the mean, you should discompute uh, 45 45 times 0 plus 81 times 1 plus 58 times 2 plus 40 times 3 plus 22 times 4 plus 4 times 5 plus and 0. 0 times greater than 5 observations, also exactly 0. And over all data, 250, and it means 107. And the variance, our variance formula is here. Our variance closely and approximately 1.61. And please notice that our variance, our mean and variance is very closely each other. So, statisticians note that patients arriving to clinic generally do so independently of each other at random intervals. So independently of each other at random intervals. The data are collected for fixed 30 minutes intervals. The mean and variance 1.7 and 1.61 respectively are quite close in value. All these factors suggest the Poisson distribution is suitable model to use. I want to again this situation why we choose the Poisson distribution in this for this problem. The first these events go independently at random intervals and in time. Our events in time. For example, 30 time, and our mean and variance respectively are quite close in value. So our mean equals 1.7, our variance is 1.61, are very close each other. The two options gives us we should use Poisson distribution. The Poisson model for the data as follows that if x is the random variable number of patients arriving in 30 minutes, then x value Poisson 1.7. Please remember that this value is lambda or mean or average. Expected value or mean 1.7, variance 1.7. Please remember that we have only one value. This value is mean. And in Poisson distribution formula is here. If you want to the probability of an event R occurring is given, probability of R means our formula run lambda to R multiply e to minus lambda over R factorial. For example, for the minor injuries clinic example, if we have our patients arriving in 30-minute intervals, then this value is general value. If you want to 0 patient come to clinic, the probability of 0 patient, you should r you should take r value 0, and the probability of zero patient come to clinic e to minus 1.7 multiply 1.7 or lambda to r 0 and 0 factorial. It means that approximately 1.8. If you want to the probability of one patient come to clinic in 30 minutes, you should use this formula, the general, and it means 1.7 to 1 over 1 factorial multiply e to minus 1.7. It means like 0.32. If you want to two patients come to clinic, the probability of two patients come to clinic in 30 minutes, 1.7 to 2 over 2 factorial multiply e to minus 7 minus 1.7. It's like approximately, for example, 2.6. And if you want to go on this probability of the patients, you should find this probability. This probability, this graph is the probability of patients come to clinic in 30 minutes, 30 minutes, and the according to this graph, you should look at, you should see the if your patients the number of patients increase, your probability is decrease. And using the probability formula for a Poisson distribution with mean 1.7, like this general, we should use the general formula. We can work out expected frequency for different numbers of patients. For example, 3 patients arriving in 30-minute interval. This means the probability means 0.15. Please remember that we have 250 observation. So if we want to work out the expected frequency, we should compute that 250 times probability. So 0.50. It's like approximately 37 times the expected number of patients. 250 multiply probability of 3 patients come in clinic in 30 minutes. We should compute to 37 to the nearest integer. This means the probability of 3 patients coming to the clinic in 30 minutes is worked out according to Poisson distribution. The expected frequency of 3 patients coming to the clinic in 30 minutes is 37 times, or from 250 data. So from 250 data, we should expect that 37 times 3 patients come in clinic in 30 minutes. A comparison of the expected frequency with the observed frequencies shows that the numbers are all reasonably close. Please notice that the table shows us expected frequency and observed frequency are comparison. For example, in Poisson distribution, zero patient come in clinic, expected frequency 46, the real in the real observed frequency 45, and one patient come in clinic, expected frequency in Poisson distribution 78, the real observed frequency 81, and also two patients come to clinic. Uh, we expect that 66 patient, and our observed frequency in please remember that 250 observation or data 58, and the expected frequency that we computed the Poisson distribution 37 patients, our data is 40 patients. And if you notice that this situation, in the real observed frequency and expected frequency very reasonably close each other. This allows us to use the Poisson distribution as a model. Using the data, the statistician makes calculation and advises the clinic that there is about 3% chance of staff being needed to deal with more than 4 patients every 30 minutes. The statistician makes calculation like this formula. Please notice that 5 patients, staff 5 patients, expected frequency 5, and 6 patients, uh, expected frequency 2, and greater than 6 or 7 patients 0. And we have 250 value over 250 value, 2% we should multiply 100, and the chance is 3%. 3% chance means more than 4 patients every 30 minutes we expect come to clinic. Key point: when modeling data using a Poisson distribution, work out the mean and variance and check if they are approximately equal. If the mean and variance are not approximately equal, the Poisson distribution is not suitable model to use with the data. Use the mean to calculate probabilities and expected frequencies. Compare expected frequencies with observed frequencies. If your expected frequencies and observed frequencies very closely, it's a very good choice for using Poisson distribution. And now, please remember that we have only one parameter. This parameter is lambda. Lambda means nu, or mean, or average. And in the Poisson distribution, lambda also equal variance. And our variance it means square, chi square, and sigma square. And our formula is r, the probability of r events lambda to r multiply e to minus lambda over r factorial. Our formula, don't forget this formula in a Poisson distribution. And now we have some example for Poisson distribution. The number of calls to a consumer hotline is modeled by Poisson distribution. The example in the example they give us already these events these events related to Poisson distribution. So we don't compare or research these events uh, regard to Poisson distribution or not, because they tell us the events regard to Poisson distribution with a mean call rate for per minute, with a mean call rate of 4 minutes, and they tell us the in the Poisson in this example our mean equal 4 per minute, and calculate the probability that in a given minute there will be 6 calls. Okay, we can start to compute 6 calls. Also, we want to compute the probability of 6 calls. In the Poisson distribution, we should use this formula. The probability R value means lambda to R multiply e to minus lambda over R factorial. So in this question, R value is 6 and lambda 4, and 4 to 6 multiply e to minus lambda 4 over 4 factorial, and B 3 or fewer calls. 3 or the probability of 3 or fewer calls means the probability of 3 call plus the probability of 2 calls, the probability of 1 call, and the probability of plus the probability of 0 call, because they tell us 3 or fewer calls. So we should compute these for about regard to Poisson distribution, and our lambda value is 4. 4 to 3 multiply e to minus 4 over 3 factorial plus 4 to 2 over 2 factorial multiply e to minus 4 plus 4 to 1 over 1 factorial multiply e to minus 4, and the last one 4 to 0 over 0 factorial and multiply e to minus 4, and the other one more than 2 call, more than 2 call. More than 2 call means x greater than 2, and it means the probability of 3 excuse me, that's 3 plus the probability of 4 calls, the probability of 5 calls, and infinity. But please notice that Poisson distribution is discrete distribution, discrete probability. So sum of the all probability equals 1. And if you want to this process, you should compute that 1 minus probability of x less than 2 less than 3. So it's very easy rather than this process. And minus uh, 1 minus probability of 2 uh, lambda to 2 over 2 factorial multiply e to minus lambda plus lambda to 1 over 1 factorial multiply e to minus 4 lambda to 0 over 0 factorial multiply e to minus 4. And if you want to this process easily, you should e to minus 4 e to minus 4 e to minus 4 multiply square 4 over 2 factorial 4 over 1 factorial and 1 because 4 to 0 1 0 factorial 1 1 over 1 1 and it means 1 minus e to minus 4 multiply it means 16 and 16 over 2 8 plus 4 12 plus 1 13. And if I want to work out these this process and e 2 minus 4 means multiply 13 and approximately 1 minus 23 1 minus 23 and it means approximately 7 7 0 0 77 is a probability of greater than more than 2 call. Okay, the last one at least one call. At least one call means one or more call. So it means the probability of one call plus the probability of two call plus the probability of three calls and then infinity. So please remember that all probability, sum of the all probability equals 1. If you want to this process, you should 1 minus the probability of 0. 1 minus the probability of 0. So 1 minus lambda to 0 over 0 factorial multiply e to minus lambda. So 1 minus e to 0 4 e to 0 4 and if we want to compute that e to 0 4 negative 4 0.018 and means 2 8 and 9 and 0 point approximately that 0.982. Okay, we will pass another question. The mean number of text messages Joel receives per day 3.4. It means text message Joel receives per day 3.4. Our lambda value is 3.4 per day. And assuming the Poisson distribution is suitable model, they already have told us this event regard to Poisson distribution, and find the probability of receiving on one day exactly 5 text message. It means exactly 5 text message. The probability of 5. And our formula again, the probability or R means lambda to R over R factorial multiply e to minus lambda. So it means uh, it means 3.4 3.4 to 3.4 to 5 over 5 factorial multiply e to negative lambda and 3.4. And the other question, less than 2 text message. Less than 2 text message means x less than 2, and the probability of 1 plus the probability of 0. And the probability of 1 means lambda 3.4 over 1 to 1 over 1 factorial multiply e to minus lambda 3.4 plus 3.4 to 0 over 0 factorial multiply e to minus 0.4. And if you if you want to compute that process, e to minus 3.4 multiply 3.4 over 2 1, it's also equal 3.4 over 1 3.4 plus 1 1 this process, and 3.4 is this, and it means e to minus 3.4 multiply 4.4. And if we want to compute that process is e to minus 3.4 like approximately 0.03 multiply 4.4 and multiply 4.4. It means 0. Approximately 0.0.14. Okay, now we have some question, but I will solve only a few question. Rest of them your homework, and I want to solve this. I want to solve this question B1, and I want to solve DE1, and the rest of these questions are your homework. for next Friday. And now we are mean 1.4, and we will compute that the probability of less or equals than 3. It means the probability of 3 and plus the probability of 2 y, our value was y, 3 plus the probability of 2 plus the probability of 1 plus the probability of 0. And our formula is lambda lambda 1.4 to 3 over 3 factorial plus and 1.4 to 2 over 2 factorial plus 1.4 to 1 over 1 factorial plus 1.4 to 0 over 0 factorial. But all of them e2 minus lambda or minus 1.4. And the other section D1 that our mean or lambda equals to 11.4. We want to compute that the probability of x greater than 8 less than 11. It's also mean the probability of 9 plus the probability of 10, because please remember that the Poisson distribution is discrete distribution, and we have no data, for example 9.5 value or 10.9 value. This is discrete data. This is discrete data situation. So it means 11.4 to 9 over 9 factorial plus 11.4 to 10 over 10 factorial. And please don't forget all of them as multiply e2 minus lambda 11.4. Okay. Now, in this lesson, we learned Poisson distribution, and we solved some question. We researched and reviewed the Poisson distribution. You have a homework. Your homework is the solution which exercise 2A, your textbook, page number 32. On your notebooks, I want you to do solution which exercise 2A, page number 32, was in your textbooks. On your notebook, the last date is, please don't forget, 14th October for this homework. I activated this homework in your Google Classroom account. Please check your Google Classroom account. After, you have to upload what you wrote there by taking photos on your Google Classroom account, or that was written. Please pay attention that the students who upload their homework in time will take 100 scores, the scores of the students who don't upload homework in time will decrease by 20 points for each day. When they return will be reported their mentor at the last of the 5th day. Have a nice lesson. We will go on the there. Have a good day.